Dear students, welcome to this lecture on textile testing. The topic that we are going to discuss today is the tearing strength testing. And before going into the details, let us see what are the contents of our discussion today. Very beginning, we will discuss what is the meaning of the word tear, and thereafter I will define what is the meaning of the term tearing strength. Thereafter, I will discuss what is the importance of tearing strength. Then I will discuss the measurement of tearing strength, and here we will discuss uh, deep description of the instrument, what is the principle of measurement of tearing testing and working procedure. And thereafter we will discuss what are the factors which affect the tearing strength of the fabric. So let us first start with what is the meaning of the word tear. Now students, from your common sense, you know what is the meaning of the word tear. Tear is basically a small cut or a hole which is produced on the surface of the fabric, and which during the subsequent usage it is elongated and converted to a long rib with some uh, small amount of force or high amount of force depending upon the type of the fabric. And this is basically the effort we are talking about. Now, remember one thing, the tearing string measures the force required to propagate an existing tear and not the force required to initiate the tear, as this usually requires a cutting of the threads. That means what I mean to say here, that means tearing string does not mean what is the amount of force that is required to tear the fabric. That is, but we mean what is the amount of force that is necessary to propagate the tear through a certain distance, right? And tearing strength is different from tensile test. In the case of the tensile testing, we apply the force along the axis of the fabric. It may be along the direction of the work or it may be along the direction of the, right? Now, tearing strength is very important. It is not only important in the conventional textile, but it is important in the technical textiles also. Technical textile means, here I mean different types like the bulletproof jackets, parachutes, tents, conveyor belts, etc. And dear students, always remember that even in the case of the conventional textile also, the tearing strength is more important than that of the breaking strength, because repeatedly I have told you in the classroom lectures also, during the usage, a dress material never subjected to high amount of force which is sufficient to break the fabric, right? But during our day-to-day use, the dress materials may be subjected to tearing force, right? Now, there are different types of testing instruments that are available, but the most common and most popular type of tear tester is the element of tear tester. And in this lecture, we will discuss the element of tear tester only, right? Now, element of tear tester is known as pendulum type ballistic tester. So let us see why it is known as the ballistic tester. In that, it is known as the ballistic tester because the force applied is very high, but the duration of the force is very small. And such kind of force is known as impact force. That means since it is working on the principle of the impact force, it is known as the ballistic testing, right? So again, I am telling it is the ballistic tester because high amount of force is required, but the duration of force is very small, right? Now let us see why it is pendulum type. You know the pendulum, it moves to and fro manner. Similarly, in the element of tear tester, the load applied is also swing in form of arc of a circle, just like a pendulum. That's why it is known as the pendulum type ballistic tester. Now remember one thing, CRT, CRL and CRE word is does not applicable here, because constant rate of loading, constant rate of extension or constant rate of traverse, these are applicable only in the case of tensile testing, right? Now let us see what is the basic principle of the element of tear tester. Now, when a pendulum is moving from from a larger, from a certain height, then it will lose its energy, right? It will lose its gravitational energy, or you can say it is lost its potential energy. Now, this certain amount of energy that is lost by the pendulum will be used up in tearing the specimen. and energy loss is equal to, that is the work done, and work done is basically the force into distance, right? Now here the energy loss is utilized in tearing the fabric. So principle will see again when I will discuss the element of tear tester. So one thing you remember, again I am telling you that here the tear stress will mean that is the force required to propagate an existing tear. That means the tear should exist, T exist. This is not like that we will initiate the tear, right? So let us see how to prepare the sample. Generally, 3 to 5 number of tests should be carried out, the warp wise as well as the wave wise, right? And we have to express the average tearing strength. But remember, the warp and wave average tearing strength should not be added with each other. That should be, we have to express it separately, the warp wise and wave wise. Now, the instrument will be supplied along with the template, and using the template, we have to cut the size of the specimen. The width of the specimen will be around 100 millimeter. All the dimensions that is shown in this slide is in millimeter. So this plus minus 2, whatever the figures that you are getting, that you can find here, that is basically the allowances that may be allowed at the time of preparation of the sample. So I am not considering the allowance right now. So you can say that the width of the specimen will be 100 millimeter. That means from this point to this point it is 100 millimeter, and the length of the specimen is 75. That means from this point to this point, this distance is 75 millimeter, right? And using the template, a slot is to be cut onto the surface of the fabric. The depth of the slot will be around 12 millimeter, and the width of the slot will be 15 millimeter. And in this here, you can see that here, this is the slit. The slit should be made using a very sharp knife, and this sharp knife is fitted with the testing instrument itself. That means this, you can say that means the fabric will be torn from this point, from this point to this point. So what is the distance from this point? So you can say that it is the 43 millimeter. So right now I can say that you have to tear the fabric through a distance of 43 millimeter, right? See here it is written the element of tear tester, the fabric is torn from the end of the slit. End of the slit means this, to the opposite edge. Opposite edge means here, and this distance is 43 millimeter, and this is the fixed. Now let us see the basic working parts of the instrument. Yes, this is the element of tear tester. You can see this is the stand of the instrument, okay, or you can see the frame of the instrument. This is the sector shaped. Sector shaped means you can say it is the semicircular. It is the basically it is the pendulum. Now the instrument is provided with two clamps. One clamp is fixed and it is onto the frame. So this is the fixed clamp, right? And this is the moving clamp. This moving clamp is attached with the pendulum. This pendulum can move in this direction. That means it can swing in this way, right? And this is the, see, this is the scale. This is the scale and this is the pointer. What is the strength of the tearing strength of the fabric that can be directly read off from this scale? Now, depending upon the type of the fabric, there are three types of weights are used. One is the 3.2 kg, another one is the 6.4 kg, another one is the 12.8 kg. So, depending upon the type of fabric, we have to use appropriate type of pendulum. Always remember that the very light type of fabric should not be used using a heavy weight fabric. Okay, so again I am discussing the working principle of the element of tester. Now work done is basically measured in the tearing of the fabric through a fixed distance by applying a sudden force. Because of this sudden force, just now I have told you that it is known as the ballistic tester, because we have applying a sudden force by using a huge amount of weight, that is the weight of this pendulum. Okay, Now, the pendulum is basically will fall from a certain height. When the pendulum will fall from a certain height, it will lose its potential energy. Okay, and when it will lose its potential energy, certain amount of energy will be converted into tearing the fabric. And energy and work is basically same. So work done, you know, it is basically the force into distance. So distance is 43 millimeter that I have shown in the previous slide. That is a fixed distance. So amount of work done is directly proportional to the tearing strength. Higher the tearing strength, more will be the work done. And what is the tearing force that can be read out directly from this scale. So let us see the working procedure in brief. So first thing is that you have to select the pendulum weight according to the type of the fabric in such a manner that tearing strength will fall within the 15% to 85% of the corresponding scale. That means you can say more precisely, you can say it should be around 40 to 80% of the scale. And I have told you that pendulums are available in 3 different types of weight. Okay. So you have to select the appropriate kind of weight. That means either you have to select 3.2 kg or 6.4 kg or 12.8 kg. Okay. Now pendulum is raised to the starting position. Starting position of the pendulum is in this. Okay. And specimen is transferred between the two clamps. So this is the fixed clamp and this is the moving clamp. So initially when the pendulum is raised, so the sample will be lying vertical between the fixed clamp as well as the moving clamp. Okay. Now a slit should be cut using the knife which is attached with this instrument. Now next we have to release the pendulum. When the pendulum is released, so naturally it will lose its potential energy, and as I have already told you, a part of the energy will be utilized in tearing the specimen. And length of the tear length is 43 millimeter. I have already shown in earlier the diagram. Next, when the pendulum makes a backswing, you have to grasp the pendulum to prevent the position of the pointer from the damaging. And after that, the pointer, you can directly read off what is the force from this scale. Now, this is a very important slide. Here you can get an idea on the mechanism of tear, right? So this is the fabric. This is the two series of threads. One is the warp, you can say another one is the weft, and tear is propagating in this direction. These are the two tails which is prepared because of the propagation of the tear, right? Now, when tear is propagating, see, when the tear is propagating in this direction, you can say the threads are accumulated here. The threads are accumulated here at this point. This is known as the delta region, or you can say it is known as the tearing triangle. Now what happens, when the tear force is propagating through this, when the tearing force is propagating through this, then what will happen, the yarns will come in group to prevent the propagation of the tear, right? Now the yarns may come single as well as in the group. Now if let us consider that the yarn is coming in single. If it is so, the single yarn can be broken easily, right? The single yarn can be broken easily, but the yarns are in the group, then what I can say, that it will be more and more force will be required. It is just like that, united we stand, divided we fall. That means if there is one yarn is in the direction of the propagation, that yarn can be easily broken. But if there is a more number of yarns or the yarns are in the group, then more and more amount of force will be required. That means what will be the tearing force, that will depend on how many numbers of yarns are accumulated in this triangle. Higher the number of yarns, more will be the tearing force, right? That means you can say that if yarns are very much free to move, then more and more yarn may come into the direction of the tear, and the tearing strength will be more. Now, in this case, I would like to mention one thing, that you will always find that for a fabric, the breaking strength is always less than, always more than that of the tearing strength. You can find one question was set in the gate or something like that. So what is the reason? The reason is that in the case of the breaking, or in the case of the tensile testing, the all the yarns are loaded simultaneously. But this is not the case of the tearing strength. Why it is so? Because tearing strength, the yarns are broken either singly or in form of groups. And more the number of yarns in the group, more will be the tearing strength. So tensile strength and tearing strength are different value. But one thing you should remember, that the tearing strength of the fabric will depend upon the tensile strength of the yarn also. Now, why it is so? Because when the tear is propagating, there are two factors are important. What is the tensile strength of the yarn, and secondly, how many numbers of yarns are there. Okay. Now, higher the tensile strength of the yarn, more amount of energy or more amount of force will be required to break, and higher the number of yarns, more will be the amount of force will be required to break the specific. Now, let us see what are the factors which affect the tearing strength of a fabric. Right. Here we will discuss the effect of fiber. We will discuss the effect of the fibers. We will discuss the effect of the yarn. We will discuss the effect of the fabric. Also, we will discuss the effect of the finish. But when we will discuss the effect of the fibers, yarn, or fabric, or the finish, we will consider their effect in isolation. That means when we will consider the effect of the fibers, we will consider the yarns and the fabrics. These are identical. That means these other properties or other variables will be same. Other construction parameters will be same. So let us see what is the effect of the fibers. The first, let us see the since that I have told you that the yarn tensile strength is very much important for for the tearing strength of the fabric. The tensile strength of the fibers will be also play a huge role in tearing strength of the fabric. Right. Now, if the higher the tenacity of the breaking tenacity of the fibers, more will be the tearing strength. Now, you know the polyester is available in the different type. It may be medium tenacity, it may be high tenacity, or it may be super high tenacity fibers. Right. So, with industrial fabric, where we need very high tearing strength, we have to use the super high tenacity polyester fibers. Next is the fiber cross section. The fiber cross section also plays a huge role in determining the tearing strength, provided the other things remaining the constant. In the previous slide, I have shown you at the time of tear propagation, it is most important. It is the very most important how much yarns are coming when the to counteract the tear force or to form the group to counteract the tear force. Higher the number, more will be the tearing strength. So ultimately, it is matter what is the fiber to fiber friction, or you can say the yarn to yarn friction ultimately. Now, if the yarn friction is less, then more of the yarns will be more mobile, and yarns are more mobile. That means more and more number of yarns can form the group, and they can counteract the tearing strength. So here you can say if the fibers are smooth, the frictional force generated govern will be less, and allowing the transverse state to slip over it easily, because the frictional force is less. So there is no resistance in the movement of the yarn, and thus improvement in the tearing strength. Now, polyester fibers, you can say it is available either in the regular circular cross section or in the tri-level cross section. So if you consider the tri-level as well as the regular cross section, you will find that there is a marginal difference, provided the other things remaining constant. And the polyester with circular cross section will have higher tensile, higher tearing strength than that of the tri-level cross section. Similarly, if you consider that the case of the polyester and viscose, here we will find there are two things is there. The first thing is that the viscose cross section is almost a serrated, or you can say corrugated surface. Okay, that means this will not allow to slip the yarns. Next is the effect of the yarn. Now, under the tearing force, yarns are usually broken singly, and tearing strength is thus roughly proportional to the single strength. This I have already told. Higher the single strength, tenacity, more will be the tearing strength of the fabric. So type of the yarn, the first you can see the continuous filament yarn and the spun yarn. You know the yarn to yarn friction is much less in the case of the continuous filament yarn. So if there is a less friction, that means more and more yarn can form the group, and naturally the tearing strength will also become higher. Next is the twist factor. The tear strength can be affected by the twist, because first effect of the twist is that up to a certain limit, of course, if we go on increasing the twist, the strength of the yarn will be more, right? And if you increase the tearing strength, that means the yarn will be more compact, thereby reducing the diameter of the yarn. Again, the next is the effect of the structure of the yarn. You can consider the two extreme case. One is the air jet yarn, another one in the case of the ring spun yarn. Now, in the case of the air jet spun yarn, because of the tightly since the core yarns are tightly packed by the wrap, or you can say the wrap by the wrapper fibers, the degree of freedom is very less, right? So more and more yarn will be degree of freedom of the fibers will be less, and the reduction in the tear string results from the decrease in the ability of the fibers to share the applied load in the delta region, or you can say in the tear triangle. Okay, so sometimes ERJ yarn we have the low tearing strength as compared with the tearing strength, but there is not hard and fast rule. It also depends on the hairiness, because if the hairiness is more, then also the yarn to yarn friction will be high. So what I mean to say here is that the two things, again I am highlighting the two things. The yarn should be mobile. There should be mobility of the yarn, because if the mobility of the yarn is more, or the mobility of the fiber is more, more and more number of fibers will come in, form the group, and they will propagate the tear of the tear in the fabric. Next is the effect of the weave. Now, if you can consider that the two different types of weave. In the one case, the weaves are such that the yarns are very restricted motion because of the more number of interlacement. That means you can say plain, where the number of interlacement is very high, or you can consider the case of a twill, where the number of interlacement is less. Now, because of the more and more number of interlacement, what will happen? The movement of the yarn will be less. The yarn will be less free to move and accumulate at the tearing triangle. And since less number of yarns are there, the tearing strength will be less. So fabric of the long floats in the weave will allow more yarn to come together, and the fabric will become more tear strength. So in this case, provided the other things remaining constant, you can say the twill weave will give more tearing strength. Why? Because in the case of the twill weave, number of interlacement will be much less than that of the plain yarn, and more yarn will form the groups and prevent the tear. Next, you can say the effect of weave on the tearing strength becomes greater as the yarns per inch decreases. In the both the twill and basket weave, there is a distinct loss in the tearing strength as the number of yarns in either direction increases. Because if you go on increasing the number of yarns, then what will happen? The amount of friction between the yarns will decrease. As a result, what will happen? Their mobility will be less. Next is the effect of the finish. We know there are two types of finish generally applied in the conventional textile. One is the resin, that is used for the anti-grease purpose, and second one is a softener, that is used for applying the soft fill to the fabric. Now, you know that in earlier classes also, when I am discussing the tensile strength and in the case of the abrasion strength of the fabric, I have discussed that what is the function of the resin. Resin will causes the formation of bonds between the fibers. So as a result, what will happen? The mobility of the fiber will very less, isn't it? Now, as a result of less mobility, then what will happen? The yarn cannot form the groups at the time of propagation of the tear. So naturally, if you apply the urea formaldehyde resin, the tearing strength may reduce up to 50%, right? But this can be counteracted by application of the softener. You know the softener, what is the function of the softener? Softener is one sort of lubrication, right? And during the it will, what it will do, it will increase the uh, lubrication effect. And softener basically, it is the mixture of two things. It is basically the macroemulsion and as well as the microemulsion. The macroemulsion, this will penetrate between the yarns and this will cause reduce the fiber yarn to yarn friction, and the microemulsion, this will penetrate inside the yarn and this will reduce the fiber to fiber friction. So as a result of application of softener, exactly what is happening, yarn to yarn and the fiber to fiber friction will be reduced and the yarns will be more mobile. And as I have already told you, the higher the mobility, more will be the tearing strength of the fabric, provided the other thing remaining constant. So we have discussed what is the meaning of the word tear, what is the meaning of the word tearing strength, what is the basic principle of the working of the popular element of tearing strength tester. We have discussed in brief the uh, the construction of tearing strength test, element of tearing strength tester, and their measurement of working principle involved in measuring the tearing strength, the working procedure for measurement of the tensile strength using the element of tearing tester, and lastly we have discussed the effect of fiber, effect of yarn, effect of fabric structure, and lastly the effect of finish onto the tearing strength of the fabric. And we have studied the yarn strength in general will depend on two things. First of all, it depends on the tensile strength of the yarn, and secondly, how free it is. Okay, higher the degree of freedom, more will be the tearing strength, because more and more yarn can form the group together and they can resist the tearing force better. Okay, so if you have any problem to understand this, you can write me in my WhatsApp or in the group, or you can talk to me over phone. Okay.